this is how you keep making newer SQL queries, okay? ERE, and what was the name of our sample 07.description, sample underscore 07, sample underscore 07. And if you do a control shift or a control space, it should automatically finish. What you're going to do is equal to legislators. Okay, so this is now what we are doing is from that table, now we have limited it even more. So now we want to see only give me what is legislators, what the number of legislators are there, and what their salary is there. Let's execute. This is standard SQL, this is not big data. It will tell you, okay, this is the output. So out of bigger data sets, you can start pulling out smaller ones using these very straightforward SQL data sets. Now these are very straightforward data sets, so we don't have to worry. But we need to now see, okay, we need to make sure we have our data that we imported into these systems itself, okay? So what was the data that we had? We had the geolocation data and we had the drugs data, right? So if you open up your command.txt file, okay, copy and paste the first one. What we're doing is we are going to create a geolocation stage data set into the default database itself. Now, for those of you who do know SQL, this is just make that table. These are the columns that we have, and this is the format that we're going to have it in. It's going to be row delimited. The fields are going to be comma separated, that is separated by a comma. It's going to be served at a text file, and just remove the first header line because that had the name of the columns in there. So Adil, if you can run this one, copy it, yeah, into there. Go down, execute. And if you go down, it will say status unknown, status succeeded. So what has happened is now if you go on, look onto the left, go up, hit that refresh button, go back into default. Do you see the geolocation table has come into that data itself? You can open that, click that, and it will tell you, okay, all of these columns that I had with the properties are there in that data set right now, okay? So now that we have that, now go on to the next command. So all of these are basically standard SQL queries, okay? Similarly, we had two data sets, right? One was geolocation, one was for our trucks. We'll run the same for our trucks as well. You can open up a new one. So Adil, if you go up, or sorry, to the bottom here, there should be a blue button that says new worksheet. If you click on the new worksheet, it will keep giving you newer worksheets. And yeah, just copy and paste that. Oh, by the way, it does line wraps really badly. So you can see that one, you pasted it correctly. Oh, yeah. It doesn't wrap your line, it just keeps going on and on and on. And that's why it is correct. You might think you're on the old one. And then execute it. And now look, go back, refresh your database. Oh, it's still running, okay. There you go, it has succeeded in creating the database, default. And so you should have a trucks.stages, trucks underscore stages. Now these are our two tables that we have created for the data that we have brought in. Now how do we put this data or the data that we had in our temp directory into these two tables? You can either use an insert into command from here and say insert into geolocation underscore stage and give the path where your CSV file is. Hive gives you an easier way. So if we go back here, that's okay. do it. 1 second, guys. I know it's a lot of stuff we're doing today, but hopefully you'll at least see what you are at least seeing what the system itself is. All right. So where is my? Yeah. All right. So let's go back to my HDFS files view, and if I go into apps, Hive, warehouse, you will see there are 2 new ones that have been created for you. So go into apps, Hive, warehouse, you'll see your geolocation underscore stage, and your trucks underscore stage has been made for you. Other, do you have that? Apps, Hive, warehouse. Are those 2 directories available for you? All that you've got to do is go back into your /10 data, move, and go to apps, I've copied geolocation. So it's telling me you have geolocation available to be pasted here, warehouse, geolocation underscore stage, and you can paste it here. Now I had already done this, so it's already there. And if you click the paste button, it should paste it into that directory itself. Okay, so this is the equivalent of your insert into table. So for people who don't know SQL, because then you'll have to learn, okay, I have to learn the insert command. So this is one way of doing it. Okay, Adil, were you able to do that? Do the same for trucks as well.
This geolocation underscore stage is automatically created?
No, when we created the table there, this geolocation underscore stage was created within the Hive system as a table. And now we're saying, okay, we're just going to insert the data from this CSV into that one. And similarly for your geolocation underscore trucks or trucks. All right, now what we can do is let's go back to our Hive view. We have our default, our geolocation underscore stage, my truck ID, all of that. Let's see if anything has come in there. So I'm saying, give me all the values. Give me only about 10 values from geolocation underscore stage. And you can see all of the values have come in. Well, I'm just looking at the first 10 values. So it tells me my truck ID number, my driver ID number. It tells me whether it is normally, whether my driver was speeding, at what position. That's my latitude and longitude my driver was speeding. Okay? And similarly, you can do the same for trucks underscore stage. Execute. It's still running. That's it's in status unknown. So now it started actually executing the query itself. I think trucks is a way bigger file, so it should be. And so right now I don't have anything in there. I haven't uploaded it. There we go. And it has said, okay, now this is what I have. Now you can start doing this in real time. It's like, let's go back to geolocation underscore stage. Limit is 10. Let's run this query again. Okay. Where different. Sorry, it should be truck underscore stage. Limit 100. Oh yeah, I forgot the where. No wonder. So it should give me an error here. Where geolocation stage equal to overspeed. There we go. So this is telling me all my trucks and all my drivers who are going over the speed limit and at what position. And you can start doing this. So if you suppose your truck driver gets a ticket, you have data that backs you up. Well, you're going over speed, so you can't fight that ticket. But if it doesn't, you can fight that ticket for a big company like this. And when your truck driver is driving, he's sending this data pretty much every minute or so. So you can imagine how much data you get from one truck. Every hour is 60. Multiplied by 24 hours a day. Multiplied by how many ever days he's on the road. If you have 100 trucks like that, you have tons of data like this. Mining this would be almost impossible different ways. And this you can do in real time as well. So you can have these, Spark systems running that start warning you or flagging you. That says, oh, your driver A54 went over the speed limit about 30 seconds ago. Okay, in real time it can start doing that as well. Now this was very static data, right? We had a flag file that we imported and we started looking at all of, we started analyzing. So this was basically, you're still using a flat file. Now, this is okay-ish data, but this is still not big data. What is the difference between this and a SQL query, right? Which is standard data. In big data, you have something which is known as an ORC. Does anyone know what an ORC stands for?
Complexity?
No. This is still not optimized. So Apache does something which is known as optimization itself. Okay? It is known as an optimized row columnar, and that is what makes your data optimized for a big data system. This is good enough for a standard SQL system, but this is still going to be really slow for a big data system. What Apache has given us is what is known as optimized row columnar system, and for that I have given you some commands there. Okay. Oh, another way, one thing I wanted to tell you was that I did not show you on this. So we were here, we have our geolocation data put in. Do we have any trucks underscore stage data? It's completely empty, right? If we do this. Trucks underscore stage. It succeeded. Let's look at the logs. Sure it shows anything. And the results. We already did load the data. So in case you did not want to drag and drop into your you could do something like this. Load your data, give the path to the data instead of an insert into. You could also do a load data and overwrite into that table itself. And I like this method better because it gives me a clean table every time, because it overwrites everything that I have. So I don't have to worry about appendages that are remaining from when I last did the same test. Okay, so this is again in your commands file itself. Now, these are good, but again, these are standard SQL. We still are not making these optimized. In order to optimize this data, let me just put out a new worksheet. You would use something known as an ORC kind of an object. So we can take, let me pull this out. So I have imported my data. What I will do is here, I have my trucks underscore stage. And I have to give it as an ORC. So let me make it a geolocation underscore stage 2, because I already have geolocation underscore stage. Oh, sorry. Nah, I don't have my, I have my geolocation underscore stage. I need geolocation too. So I'm going to save it as geolocation too from geolocation. So it will run, it has succeeded. If I look at this, default hash. Do I not have geolocation 2 yet there? Says succeeded. There. And this is what is known as, and just this one command converts a standard SQL table into an optimized row columnar table. And this is way better for running all of your queries against than a standard SQL. And how do you check whether your data table itself is optimized row columnar? You can say if describe formatted geo, let's see, location. Execute. And in your result, it will show you that it is ORC optimized. Do you see that input format is ORC, your IO, and your IO is both ORC for input and output. What this lets it do is work through your HDFS file system way quicker than it would on a standard SQL file system itself. Okay? All right, so this makes it row columnar. Now now we have all of this data. Can we do some analytics on it? Let's run some very simple queries, okay? Now, beyond this, it's all going to be standard SQL queries that you're going to be looking at. Where is my mouse? There we go. So we can do the same. You can optimize your truck underscore stage also as trucks. That's what I've already done. Our geolocation underscore stage. This was the staging data. This is my actual database that I'm looking through. Let's run a very simple analytics. Now this is saying select my truck ID, average miles per gallon from truck mileage, and group by my truck ID. So it will tell me select truck ID group by from truck underscore. I haven't created truck underscore mileage. Let me just create truck underscore mileage. Create a new table called truck underscore mileage. And what I'm doing in that is I'm taking a lot of this data, mixing it, and finding what my miles per gallon, all of that is. Okay, and all of these commands I have put in there because I didn't want you to have to type hundreds of lines of code. So just get that and let's execute that. Succeeded. Oops. Hit execute again. And this is something you have to be careful of when you go through these huge lines that don't wrap around. Table already exists, so it was already there, so I did create it first time. You can see truck underscore mileage is now here. Let's go back here, create a truck ID. This is the good thing, if you create multiple worksheets, you can keep it on different tabs. There we go. And you can say, okay, my truck A1 was giving me this much mileage, and you can again start doing this in real-time querying itself. So you can say, okay, if it goes beyond or beneath a certain level, maybe I need to look up what's going on with this truck because it's only 4.6 miles per gallon or 4.4 miles per gallon. Maybe that's up time for service. And so you will be mining data like this, like this. Now this is, why did we look at this? Why did we look at this kind of a data analytics? Now you can see these results were coming way faster because these are ORC. And now this is not too big a file for you to actually see the difference, but from a standard SQL to an ORC, if you have millions of lines of data, standard SQL might take a couple of hours, and ORC might give it to you in a couple of minutes. So that is the difference. So that is how faster optimized row columnars are compared to standard SQL. So basically, if you're a data scientist, this is what you're going to be looking at first. And then within this commands itself, you can also look at, see if there is any output that it is giving you. You can drag and drop your X, Y's and say, okay, this is what the chart is. Can you plot it out for me within this itself? Then you have your visual explanation. So it tells you some where I have done. So this is telling you what my actual big data thing I'm doing is. So again, which is the table I'm looking at, where I'm grouping by. You remember our key value pairs? What key values were you looking at? So this was my map phase, right? Then I did a shuffle and sort. This was my reduce phase. What my key value pairs were, and then sort order I didn't give any. We said just give them in whatever it is. We could have said give that sort by mileage, and then it would have given me a sort order as well. And then it would have said, okay, this is what I'm sorting by. So this is why I like the Ambari system, because you can see, visualize this where you want it to go. Okay, and then there stays, and you can, now it's telling me you can send this out as an email also to whoever you want to send out, that this query is ready to be sent out. All right, I think that's about all I want to force on you in about an hour and a half or hour and 40 minutes, not more than that. Because what I would like for you guys to do is, when you get home, you have these geolocations and the trucks. Just try running some analytics on them. Play with this system. You don't have to do this within SQL itself. Play with the system any way you want to, and you can so you can actually add modules in this graphically if you want to. You've already seen this. Just play this with this. So this was, and then it can also look at your history of the queries that you have saved. Okay. This was Hive itself. You can look at Yarn as to what Yarn does. So it will tell you, okay, where my resources are going. It will of course take some time to get all of the things that you have. Now, Yarn we said was a resource manager, so we'll give you more of information. I have only one node. That node, no node has been lost, no node is unhealthy, no node had to be rebooted, no node had to be recommissioned. Had I lost a node, Yarn would have said, okay, one node had gone into unhealthy, but I lost it and I had to recommission. I had to decommission it and put in another node that, and I did not lose data on that. So Yarn would tell you all of that. And this will tell you a lot more data if you're on a cluster itself. Right now we are on a single machine, so Yarn is not showing us any more data. Let's look at what the MapReduce tab also shows us. Just go through. It just tells me I have started a MapReduce client, because the Hive that we ran, when we looked at the graphical, it still had a map and a reduce phase that was running on this MapReduce client. So you have one MapReduce, 2 clients installed, okay, on this system. Then you can go into Tez, and that we have Hive. Hive server, you have one Hive client installed. Pig, one client is running, you could be running the same. So in order to run with Pig, you go here and say, okay, Pig. Now let's see what all I can play with in Pig. So it is doing its testing all of my connections. Now, Pig is written in something which is known as Pig Latin. So Pig is a higher level abstraction. You're not going at the lower levels. It has its own syntax, and that is known as Pig Latin. So you can write fairly straightforward human readable scripts that the your Hadoop file system can understand, and you can put it into UDF containers. Let's go back to Ambari dash. Let's go back to our Ambari. Then you have Scoop, you have Uzi. That is also saying we have Zookeeper, that's again monitoring, telling we have some stuff started. Nox, you're not going to use Spark, maybe, maybe not. Mainly what you're going to be dealing is going to be Pig, Slider, Taze. So in Taze you can start up your own view, similar to what we did for Hive, and it will tell us, okay, this is what we've already done here. And what Taze does is, so Taze gives you a graphical approach or a graphical representation, and that graphical representation is given through DAGs. Does anyone know what DAGs are? Directed acyclical graphs. So it is a graphical method. It's like a flow chart, but they follow a particular workflow. Okay? So DAGs are also something you might just want to keep at the back of your mind. So these are the kind of questions they ask you when you go for a data scientist interview. It's like, okay, what is a DAG? How can you define workflows? What is the first thing you'll probably do after setting up an HDFS file system? After you, what is the first thing you would do after importing data into an HDFS file system? So there are some things that you would do. One thing that we didn't look at here because our data was really small was the veracity of the data. We didn't check to make sure that our data is good. We haven't done that. And also we did not check once we moved data from one place to another that the data itself has copied properly. The file might have succeeded copying, but when you have maybe a 50 gig file or a 60 gig file, you need to make sure that what file was available at the source is the same that is residing on your HDFS file system right now. And for that, there are multiple ways. One of them is known as an MD5 checksum. So each file you can run an MD5 checksum, so it will give you a 64 or 128-bit checksum for that, and you can compare those two. Even if one bit in that file has changed, your MD5 checksum is not going to match. Okay? So again, that is again one thing they usually ask in interviews is how would you verify that the files that I have on two different servers and two different locations are the same? Other than that, I think that should be. Yeah, I know they're already like, okay, just shut up and stop talking. It's so long.
I think they enjoy it.
I'm not so sure. It's very dry unless you actually keep doing it. Hopefully, some of them actually could do it. But
Well, that was a good introduction, I think.
Yeah.
You can always build your knowledge on this.
Yeah.
It's never going to happen all at once, as we know. It's like iterations. You know, the first time you get exposed to something, it takes a while to sink in, and then the next time you try it, you understand even more. And that's how you should do it. You know, you should persist, not just say, okay, I've done this, that's it. You know, I know everything about big data. There's so much to know, and the only way to learn it really well is to keep at it. You know, don't just stop at it at this point. You know, play around with things.
Mhm. And now they have the sandbox and set up a system also
so you have
for
everything
them.
you need to get started.
I was just gonna say, because I didn't bring the laptop, I started
An Azure.
an Azure instance
You did
of
it?
the sandbox,
Excellent.
and
It
it
works
was
just fine.
yeah,
Same
it was
way.
super easy.
Yeah.
You
Yeah.
can log in
Very
through
good.
the public IP and do the
Excellent.
SSH and everything.
So, and if you want to, once you're done, you need to make sure that your computer is available for yourself. So make sure you shut down the server that you're running. So it's just
Oh, okay.
shutdown -H now. That's the standard Unix shutdown command.
No, if they have a question, can they email you?
Oh yeah, they can email me.
Okay. Do you have his email?
anytime. Yeah.
Yeah, I think
I actually hired 2 of them this week.
Oh, really?
Yeah.
Which ones?
Harsha and
Who are the lucky
Avinash.
ones?
Avinash. So
For that center.
yeah, for CPSC, they
Yeah.
were working in the
Okay,
big
very
data
good.
lab, and
That's a good step.
so they'll be also helping setting up servers. And by the way, if you guys want to volunteer, always feel free. I can always use free labor. But I promise you learn stuff. That's
Yeah.
about the only thing I can promise.
That's a fair trade.
Yeah, that's about the only thing I can
You work
promise.
for free,
And
but then you learn.
and when we do get grants, I will be able to hire some more people. So right now I got some money to hire folks, so that's why I could hire some
Yeah,
folks.
I
But
encourage
yeah,
you to do so.
Yeah.
If you
yeah, if you want to, because we have
How
systems in
many
there.
possible
maybe another two or three more, not more than that.
Yeah.
So,
And then in the future, they may.
and then
If they let you know.
yeah,
first.
exactly.
Okay.
So,
Okay, do they have something to do to work?
other than so on the on this link, you have another bigger data set which is about 500,000, maybe between 500,000 to 5 million records. You can download that data set also, import into HDFS, and try running some queries. That's also going to be a straightforward type.
I'll talk to Thomas after class, and then I'll post some assignment for you. Because it's very important that you really apply yourself in a serious way to solve something, right? Even though you may not like it, but it's good for you. It's like medicine. So we'll put something for you to force you to do some, to use this knowledge that you have, and maybe even learn it at a deeper level as you start working with it.
And we're close to the end of the
Right.
semester, so
Right.
I didn't want to give them an assignment to do.
No, I have to.
Yeah, exactly. So like that's Dr. Julian's.
Now, for next week,
Mhm.
we have
We
another
have-
guest speaker.
yeah, we
If
have
you want to just
John
give them a
Paul.
brief idea of who.
So John Paul Robinson, he is UAB's grid architect. He's one of the cloud computing experts pretty much in the state of Alabama, because we had the biggest cloud platform, the biggest academic deploy actually in the country. In 2012, we had half a petabyte on a cloud platform with 192 cores, about 2 terabytes of RAM on that system. That was a very big system for back in the day. Now it's tiny. We have a newer system which is 6 petabytes, and he's the one who's architecting that system. So he's worked on OpenStack, he's worked on Azure, he's worked on Amazon. He hasn't worked on too much, but since we moved
We
to,
have.
yeah, you guys have worked to Amazon, you've worked on Amazon. So what he can do is explain to you the stack of how a cloud works. And it can be your own private cloud that you have. I have my own cloud, and it's actually built on something which is known as OwnCloud. This is the platform, OwnCloud. UAB has something on OpenStack. We pay for Azure from campus because all of your Office 365, all of your storage, all of your email is actually on the Azure stack. So remember those two papers that I gave you in the slides last week? Just go over them, go through those papers, and be ready with questions to ask him any question you have on cloud technologies. What I'm not sure how deep he can go in a 2-hour session, but believe me, he knows what he's talking about. I worked with him for 5
Well,
years.
they have some background. in
Yeah,
cloud,
and
so-
you have some background, so ask him any question you want to. Okay, and he's fun to talk with. He's a regular guy like us, so.
It
he's
should be
fun to
very
talk.
interesting
It
talk.
should be very interesting. I'm interested in sitting
Will you
on
be
that.
here?
I'll be here for that. I was supposed to be on vacation for the last Thursday, Friday, this Thursday, Friday, next
Have to wait
Thursday,
until the
Friday.
end of the month.
Now I have to wait until the end of the month to be on vacation. So yeah, make sure you do read those papers though, because those are important.
Well, last time we talked about the size of the big data, so I have some facts. So by 1996, there was so much data and computing had gotten sufficiently inexpensive that digital storage became more cost effective than paper systems for the first time. Storing data on electronically has become more efficient
Then page.
than paper by 1996. So that's one fact. In 2000, 25% of the data was stored digitally. In 2007, it reached 94%.
Yep.
90% of the world's digital data has been generated over the last 2 years. Every year, the amount of digital data grows by 50%.
Yep.
Every minute of the day, this is every minute of every day, 204 million emails are sent, 2.4 million pieces of content are posted on Facebook, 72 hours of video on YouTube, and 216,000 new photos are posted on Instagram.
Every minute.
every minute of every day. I mean, this is like astronomical numbers, not even earthly numbers.
Yeah. Yeah, we used to think the universe is so big.
We're exceeding that.
And we are actually, data-wise, our data of digital universe is becoming so big that UAB actually started a new position, which is this. Director of Digital Data Curation Strategies.
Oh, that's a typo.
And whenever the guy starts his talk, he has his name on here and then adds this on the bottom. WTF for his title. Because he says, even I don't understand what my title is. That's the way it is. A very smart fellow, but this is what UAB has, because that's how the universe of digital data is evolving on that scale. UAB generates about a petabyte of data every year.
Okay, but that's nothing
Compared to what?
So industrial firms are embedding sensors into their product to better manage their supply chain and logistics. The sum of all this is the creation of 5.6 zettabytes in 2015. In 1 year, they have generated 5.6 zeta. In case you're wondering what a zettabyte is, it's 2 to the 21st. This is in 1 year. I mean, this is like more atoms than you have in your body.
So there is one number again in big data. I forgot to tell you guys, since we're talking about if they decide to go in. Do a Google search for this. Google. Yeah, this is the word from which the word Google actually came out of, and it's 100 to 100. And then there is a Googleplex, which is a Google to a Google. And they say the Googleplex is actually more than every atom in the universe put together. That's what they say. Let's see, with big data, we might break those very soon. But 100 to 100 is still a big number. But then when we sent man on the moon, we had what, 16 kilobytes, 32 kilobytes, right? That's what we had when we sent man on the moon. Today we have 100 million billion times more than that. So the scale changes.
Well, thank you so much for the 2 lectures. And we're fortunate to have Thomas in our department, and he will continue to be a good resource for us, even in the future. If you have questions, I'm sure he will be happy to talk to you. Okay, let's switch back to the course. How are you doing on your project? As you know, it's due next week. Are you okay? Do you have something you can impress people with? What do you think? Or is that?
I'm still working.
But do you have? Well, it's a good sign that you're working, but is it going the right direction? Yes. Good. Good. That's the main thing. I mean, I don't expect you to stop working a week ahead of time, but as long as you feel like you're making good progress. Okay, so next week we'll have to talk on the cloud stack, and then it's not going to take up the whole period.
No, I don't think so.
Yeah. So we'll devote some time for the presentations, and then afterwards, after the class time, then we'll continue with the presentations. Okay? All right. Do you have any questions for me? Yeah.
The presentation is just the demonstration of the app, or
The presentation?
just the demonstration?
No, you need to send me the code also.
I mean,
so-
but when you show.
Oh, when you show that, that's just that.
Just demonstration
Yeah,
of the app,
yeah.
not the real
Yes.
presentation.
Right.
It's been about 5 minutes.
Yeah, keep it to 5 minutes, because if you want to show something, if you cannot do it in 5 minutes, that means you don't really understand it yourself.
You're going to do it here in the class, and you continue after the class?
Yes. Yes. And it's on a volunteer basis, whoever wants to come first. If nobody wants to come, then I'll call names.
So you heard what Dr. Julian said, if you can't explain it in 5 minutes, you really don't understand what you're doing. Well, I think I had an 3 hours and 50 minutes, and I don't think I did a good job then.
You can tell he's confused. All right. I guess we'll leave early today, if you don't, unless you want to stay around. Okay, we'll see you next week.